Right now, 16 billion miles from where you're sitting, a team of engineers is about to attempt something they have never tried in 49 years of flying this spacecraft. If it works, a piece of Voyager 1 that went dark just months ago could come back to life. If it fails, that silence becomes permanent. No overs. No second attempt. Just one shot, sent at the speed of light, and a 44-hour wait to find out what happened. This is not science fiction. This is not a simulation. This is happening this month, in July of 2026, to the oldest still operating spacecraft humanity has ever built. And almost nobody outside a small team at NASA's Jet Propulsion Laboratory is paying attention to it. I'm your name, and this is your channel. If stories like this are what you come here for, subscribe now, because we're about to go deep into what's actually happening out there. Let's start with where things stand. Voyager 1 launched on September 5th, 1977. It was supposed to last 5 years. It has now been flying for nearly 49. It is the farthest human-made object in existence, currently more than 16 billion miles from Earth, deep in interstellar space, the region beyond our solar system's protective bubble, the heliosphere. No other operating spacecraft has ever been out here. No model built from Earth has ever been fully tested against what this environment is actually like. Voyager 1 is our only live witness, but being the farthest, oldest spacecraft in history comes at a cost, and that cost is power. Voyager 1 doesn't run on solar panels. It's too far from the sun for that to work. Instead, it runs on something called a radioisotope thermoelectric generator, or RTG. Inside are containers of plutonium-238, slowly decaying and releasing heat, which gets converted into electricity. At launch, this system produced about 470 watts, barely enough to run a couple of hairdryers. Today, after nearly 5 decades of decay, it produces a small fraction of that, and it keeps shrinking every single year, losing a few watts annually with no way to refuel it, replace it, or slow it down. Of the 10 scientific instruments Voyager 1 originally carried, most have already been shut off, not because they broke, but because there simply isn't enough power to run them anymore. Every instrument still operating as a hard-won survivor, kept alive by engineers making brutal trade-off decisions about what to sacrifice and what to save. And on April 17th of this year, one more instrument went dark. NASA sent the command to shut down the Low Energy Charged Particles Experiment, LECP for short. This is not a minor instrument. LECP measures the structure of the space between stars. What are the actual texture of interstellar space, cosmic rays, solar particles, the pressure waves rippling through the void. It's one of the tools that helped scientists confirm the exact moment Voyager 1 crossed out of our solar system back in 2012. Losing it means losing a direct sensor into a part of the universe we may not get another chance to study for decades. Here's the thing, though. The team didn't shut it down because they wanted to lose it forever. They shut it down to buy time for something bigger. NASA engineers have been quietly working on a plan they've internally nicknamed the Big Bang. It's not a bomb, and it's not a discovery. It's a power maneuver. The idea is to restructure how electricity flows through Voyager 1's aging systems, squeezing out extra capacity from components that are currently running less efficiently than they could be. Done right, it could free up enough power to bring LECP back online. Done wrong, on a spacecraft with no manual override, sitting 16 billion miles away, with commands taking over 22 hours just to arrive, it could cause damage nobody can predict or reverse. So the team didn't risk it on Voyager 1 first. They tested it on its twin Voyager 2, which has slightly more power to spare and is a bit closer to home, making a failure marginally less catastrophic. Those tests ran through May and June of this year. And now, this month, July 2026, if those tests held up, the same maneuver is scheduled to be attempted on Voyager 1 itself. Think about what that actually looks like from inside the control room. Every command has to be triple-checked because a mistake sent once across 16 billion miles cannot be taken back mid-flight. You send the instruction. You wait roughly 22 hours for it to arrive. You wait another 22 hours for confirmation to come back. Nearly 2 full days for a single exchange. And they are doing this on a machine assembled with technology from before the personal computer existed. A machine with less onboard memory than a single modern text message. This isn't the first time this team has pulled off something like this. In 2023, Voyager 1 nearly died for real. For 5 months, it kept transmitting, but the data coming back was scrambled. Unreadable gibberish that even veteran engineers who had spent decades learning to read this spacecraft's signals could not decode. The cause turned out to be a single memory chip that had physically degraded after decades of constant cosmic radiation exposure. The fix wasn't to replace the chip. That's obviously impossible at 15 billion miles. Instead, engineers relocated the corrupted code to different sections of the spacecraft's remaining memory, piece by piece, verifying each fragment across weeks of 44-hour communication cycles. It worked. Voyager 1 came back online in 2024, fully readable, still delivering science nobody expected it to still be capable of collecting. That history matters here because it tells you something about this team. They have made a habit of refusing to let this spacecraft go quietly, and they're trying to do it again. Now, why does any of this actually matter to you, watching this on Earth in 2026? Because Voyager 1 isn't just old hardware racking up frequent flyer miles through the galaxy. It is sitting in a region of space that no other instrument in human history has ever directly sampled. The space between stars, just outside the boundary that shields our entire solar system, including Earth, from the harshest radiation the galaxy has to offer. Every piece of data LECP collects out there is a direct measurement of the environment pressing against that shield. If NASA loses that instrument permanently, we lose one of our only working senses in a region that directly affects the safety of everything inside our solar bubble. And there is no mission currently funded that could replace it. If a new interstellar probe were funded and launched today, it wouldn't reach the same boundary for at least 25 years. Which brings us to the second thing happening to Voyager 1 this year that almost nobody's talking about. On November 18th, 2026, just a few months from now, Voyager 1 will cross a distance from Earth that no human-made object has ever reached. 1 light day. That means a signal traveling at the fastest possible speed in the universe will take a full 24 hours just to reach it, and another 24 hours to get a response back. Send a command on a Monday, and you won't know if Voyager 1 even received it until Wednesday. It's a strange kind of milestone, not a discovery, not a dramatic event, just distance. But it marks something no civilization before ours has ever achieved. An object we built, still transmitting, still functioning, crossing a threshold that far into the dark. And riding along with it the entire way is the Voyager. Golden record, a gold-plated disc carrying greetings in 55 languages, the sounds of Earth, and a map showing whoever might one day find it exactly where our planet sits in the galaxy. Long after Voyager 1's power runs out completely, expected sometime in the early 2030s, that record keeps traveling. No friction to slow it, no atmosphere to burn it up. It just keeps going, carrying a piece of us for longer than anything else we have ever made. So here's where things actually stand right now in July 2026. An untested power procedure is being attempted on the oldest functioning spacecraft in human history. If it works, a critical scientific instrument studying the space between stars might come back online, extending humanity's only live window into interstellar space. If it doesn't, that window narrows a little more, on a machine that's already losing power every single year, with no way to stop it. Nobody at NASA is promising this will work. They're not calling it a sure thing, but they are trying. Because with Voyager 1, betting against this spacecraft has never once paid off. The signal is still coming, delayed by over 22 hours, carrying information from farther away than any human object has ever reached. About a part of the universe we are only just beginning to understand. And this month, we find out whether it keeps coming a little longer. If you want to know what happens when the results come in, subscribe and turn on notifications, because we'll be covering it the